delivering so many presents to the entire world's children is no easy task. Santa violates a very large amount of aviation laws, but considering how he hasn't been intercepted by a fighter jet indicates that he probably has some special arrangements with the world's governments to deliver these presents. Insert Santa conspiracy here. But that doesn't mean he can. Delivering all those presents to all those world's children in one night is as impossible as me getting over 100 subscribers. This sleigh must be moving at an incredible speed, and well, we can calculate that with the immense, undefeatable power of math and a few hours of my time wasted. Now, I've seen some figures for this online, but the speed ranges anywhere from 30 to 40 kilometers a second to 97% of the speed of light. And even though it's impossible to calculate these figures precisely, that's just an unacceptable margin of error. And this is why I decided to put matters on my own hands and give my own calculation of how fast I think Santa's sleigh goes. For the sake of making this easy and also for fairness, I will be assuming that Santa delivers presents to every child. Many calculations use the average distance between households for calculations, but that leaves many variables unaccounted for: population density, distribution of households, and the like. I'll be using a much simpler solution: the total length of all the roads on Earth. You need roads to get to households, right? So the total road network length is 64,285,009 kilometers. Of course, there is going to be distance not covered by roads, i.e. oceans. Surprisingly, the ocean length is actually really small compared to how much roads we have, which just proves how much stuff we've built. So a rough estimate will do. I chose to measure the width of the ocean myself, unfortunately not by going on a boat crossing the Atlantic and holding a very long ruler, instead by using the measure distance feature on the Google Maps app, finding the distance between two large coastal cities relatively on the same latitude. The distance from Shanghai, China to Long Beach, California is 10,450 kilometers, while the distance from New York to Lisbon, Portugal is 5,395 kilometers. Obviously, Santa will probably travel a few hundred kilometers more or less than this, depending on the path he takes, but in this order of magnitude, I don't think it really matters. So the total length he will have to travel will be 64,285,009 kilometers, plus 10,450 kilometers, plus 5,395 kilometers, which equals 64,300,854 kilometers. The speed is distance over time, and we will now find the time Santa has. I'll assume Santa starts when the sun first sets on Christmas Eve and ends when the sun last rises on Christmas Day. The sun will set first in some parts of Kiribati, which is UTC plus 14, on Christmas Island. Geez, even the name of the island is trying to make a bad pun. On Christmas Eve of 2020, the sun will set at 6:28 p.m. local time, or 4:28 a.m. December 24th, 2020 UTC. The sun will rise last in American Samoa, which is UTC minus 11. Technically, there's some places that's UTC minus 12, however, no permanent population listed, so I won't be taking that into consideration. In Pago Pago, the capital of American Samoa, the sun will rise at 5:54 a.m. local time on Christmas Day of 2020, which is 4:54 p.m. December 25th, 2020 UTC. This is 36 hours and 26 minutes to deliver the presents, which is 36.4 hours or 131,160 seconds. We can now find the speed as we have the distance and time. The result is around 1.76 kilometers per hour or 490.2 kilometers per second. This is a pretty reasonable solution. It's a middle ground between all the answers I found online, and since no one has done it the way I did it, I guess it makes my solution actually quite reliable for a rough estimate. For comparison, when the Parker Solar Probe passes around the sun, it became the fastest man-made object, at least in our world, at 200 kilometers an hour. However, Santa's sleigh is around 8,000 times the speed of that. It's even faster than Sonic the Hedgehog, so instead of saying Sonic speed, I guess you should say Santa speed? Well, this is no match for the speed of light. It is faster than the fourth cosmic velocity, which is basically fancy talk for saying if Santa pointed his sleigh in the sky, went at full speed, and kept going, he could get out of the Milky Way. But then this just makes me have more questions. For example, how heavy is Santa's sleigh? Let's say the average present is a pound. There's 2.2 billion children in the world, meaning that the presents are 2.2 billion pounds. We can then find the kinetic energy using a formula, which gets us 119 million terajoules, or roughly 1.9 million times the power of the Hiroshima bomb, or 28 quintillion calories. A carrot has 25 calories, so Santa needs 1 quintillion carrots for his reindeer, or 143 quadrillion carrots for just one of his 8 reindeer, just for this one trip. How could they even manage to eat all this? This is 4,700 times more than the amount of cells in our body. Say the world gave all of our carrot production to Santa. It would take 27 million years to produce this many carrots. If we lined up all these carrots and put them all in a row, the length will be 21.14 light years, meaning that it would take 21 years for light to travel this distance. This distance extends out of our solar system all the way to the Gliese 581d system in the Libra constellation. And I also estimated the volume of a carrot using a cone. And the sum of the volume of all these carrots adds up to 83,776 kilometers cubed, enough to fill the world's largest freshwater lake to the brim with carrots. And that's just for one trip. Plus, this is an extremely oversimplified model. It's only the horizontal kinetic energy, all the stuff that's way too hard to calculate, such as energy loss and inefficiencies of converting food, energy into motion, wind resistance, the energy needed for takeoff and landing, etc. are not taken into account whatsoever, so realistically a lot more energy would be needed. But doing that is extremely complicated and unnecessary for what we're doing anyway, since these numbers already show the sheer amount of carrots Santa's reindeer would need. And let's not talk about the pure amount of labor Santa's elves would need to do. Clearly, Santa appears like he is an omnipotent being, with nearly unlimited access to energy resources, as well as carrots, cookies, and milk and mince pies. Maybe the holidays are literally magical, but maybe we're taking the story of Santa a bit too literally. When we ignore all the stories, the tale of Santa is a simple one. Just another man who wishes to give to the people, instead of the chubby man with a slight obsession with mince pies leading a worldwide operation we usually see in the media. Maybe the story of Santa is supposed to be more symbolic, representing the love and kindness of people sharing gifts in the merry season. And maybe putting too much science into this is pointless, as Santa's story was never intended to be put this way. After all, it was just another story. But regardless, the story of Santa is definitely a fun one, and these nice warm fuzzy feelings the holiday season gives me will continue to linger within me forever. Maybe combining math and science and the holiday season, which are some of my favorite things, isn't such a bad idea after all. But we all know the true reason why we like Christmas. It's because it's a break. Heya, I guess that video was my Christmas present to you guys. And your present to me will be a sub and a like. These things really make my day. Oh yeah, and comment and turn on notifications too. All those things don't even require an overweight man to deliver them to me. So again, sub, like, comment, notifications, since I make quality monthly content like this. Well, happy holidays and see ya next month. Have a good one.